Thank you for joining us today for a webinar with John Nestor, Senior Architect, and Dragos Manolescu, Senior Software Engineer at the Whitepages. My name is Laura Masterson. I'm going to be hosting the webinar. John and Dragos are going to be presenting their experiences converting from Ruby to Reactive. Before I hand the floor over to them, I just wanted to go over a few housekeeping items. First of all, the webinar is going to be recorded today. We're going to post the slides and the recording on our website within a day or so. Secondly, if you have any questions throughout the presentation, please just insert those into the little chat box on the lower left-hand side of your screen, and I'll do my best to address those as we go, saving some of the more technical questions for John and Dragos at the end of their presentation. So with those, I'm going to hand the floor over. John and Dragos, thank you so much for being with us today, and the stage is yours.
Thank you, Laura. Good morning, everyone. This is John Nestor at Whitepages. For roughly the last year and a half, Whitepages has been in the process of converting a number of our high-performance back-end services from Ruby over to Scala. And this morning we wanted to share with you some of our experiences in this in the hopes that they might be of value to you as well. A couple of disclaimers up front. One is a lot of the material is very subjective, and what you're hearing is the view of Dragos and I and nobody else. This is our personal view, although hopefully some of it might resonate with you. The other thing is I think each company and each group is a little bit different, and what worked for us may not work for you. On the other hand, again, hopefully by sharing some of this with you, you might at least pick up a few ideas if you're going through similar transitions from Ruby or maybe other languages into the reactive Scala Akka world. I also wanted to point you, there's a link here which you can look at later. There's a Whitepages Typesafe case study on the Typesafe page, and it talks about some similar things to what we're talking about today, so I suggest if you get a chance you might want to go check that out as well. So with that, our talk today has basically three parts. The first part on background, we're going to give you a little bit of context about Whitepages and what's going on here and how Ruby and Scala fit into that. And then the two main pieces, the next one's going to be about technology. What technologies did we use, and what was our experience with those technologies, particularly from the perspective of bringing Ruby people into those technologies. And then the final section, we're going to talk about people. Developing software is very much about the people doing it, and we've got a transition here where we're taking Ruby people and moving them over to Scala. And some things worked and some didn't. So we're going to share some of our thoughts and experiences with that. So with that, I'm going to turn it over to Dragos, who's going to go through the background section.
Good morning, everybody. Glad to have you all here, spending a little time with us to hear about our experiences. Let me tell you a little bit about Whitepages. We are one of the top mobile sites for finding phones, people, and locations. I have some numbers on the screen that speak about the number of users and the type of usage that we get on our website. We have both a web app as well as a mobile app running on multiple platforms. And typically people come to one of our properties either on the web or on their phones when, for example, they're interested in finding someone they would like to get in touch with, they would like to see who's bugging them on the phone and they have only a phone number, or they want to verify someone's address. So these are all instances of people using our properties. Now, Whitepages started as a collection of Perl programs that were providing answers to these queries. And as the company grew and the traffic increased, as well as Ruby was getting traction out there in the market, the shift has happened from Perl programs to a set of Ruby components. Some of these components were helping on the front end. This is where the Rails fits in the picture. And some of these other Ruby components were implementing the logic on the back end. However, as the company has gotten increasingly more traffic and the amount of users, concurrent users on our website has increased, we have started to see growth problems. For example, we saw problems with the responsiveness of our site, and users started experiencing increased latencies as they were placing their queries. We also saw problems with resiliency. We use a set of external services, data providers, and our software was increasingly sensitive to their problems, to the upstream problems. And last but not least, we were noticing problems with scalability. We had a high resource consumption with the number of users increasing on our website. So if you think about it, if you think back about the reactive manifesto, you see that all these traits that I have covered, responsiveness, resiliency, and scalability, are things straight from the reactive manifesto. So that's the tie into the title and what we'll be talking about next. So the time has come for us to move away from Ruby to something that would help us cope with the amount of users and scale gracefully. And we looked around and we chose Scala as the language of choice for this shift. Several reasons for Scala. From our vantage point, Scala does a great job at successfully marrying the functional and the object-oriented paradigms. It provides the luxury of a static type system, which is in contrast to Ruby. And the static type systems helps in multiple ways. First of all, at development time, the compiler detects problems way before you run your code. And second, also due to the static type system, the compiler can optimize code because it has additional type information that is not available in a dynamically typed system. Another reason for that is the fact that Scala runs on top of the Java virtual machine, which means that it can reap the benefits of all the research and hard work that got into garbage collection and performance tuning that the Java community has built on top of, as well as leverage the mature ecosystem that was available with Java. And this is a contrast from other languages that do have a bootstrap problem, for example, Go or Dart. So for Scala, the bootstrap problem has been resolved. And another aspect that I want to throw in here is not necessarily part of the language in and of itself, but it is something that it's becoming a fact of reality, and nobody would want to build distributed systems without a weapon like this under their belt, is the actor-based concurrency framework, ACA, that helps deal with distributed systems and computations, as well as the ideas that ACA has borrowed from, for example, Erlang with supervision and resiliency to failure, all of which are attributes that we're interested in. So with Scala, armed with Scala and ACA and the ecosystem that I have just talked about, we built a set of reactive services that have been replacing incrementally our back-end Ruby services. From an architecture perspective, if you look at our architecture, we have a set of services that are loosely coupled and communicate with each other over HTTP, exchanging messages encoded either in Thrift or Json. We have sensitivity points in this type of architecture with respect to latency and throughput, as well as with respect to instrumentation. We want to know exactly how our services are doing, what is healthy, what is not healthy. Diagnostics, we want to be able to spot problems that may appear and fix them quickly, as well as agility. We want to be able to quickly develop, test, deploy, and pretty much repeat this cycle really quickly. And our architecture, the decomposition into services, as well as the choice of tools and languages, Scala in this case, lends itself very well with these goals. So after we transitioned some of our services from Ruby to Scala, we ran some measurements to derive some numbers to quantify how is the new architecture doing, what is the impact of Scala, and is this a direction we want to continue in. So let me share with you some numbers. These are numbers from the case study that John mentioned earlier at the beginning of our call. And this is one of the services that we have, a directory service on the left-hand side, and we have numbers for the two implementations, the Scala-based implementation and the Ruby-based implementation. I will let you go through the numbers. I'm not going to read them to you, but you see there's a big difference between the two services. One thing to keep in mind here, and as I mentioned earlier, we have dependencies on upstream components, external data providers that entail our making network calls. So the benefit that you see here is due to changing the implementation and the language and the way we deal with network calls and the asynchronous programming model that we're leveraging, not caused by changing our sources. So the sources that we use in both services are the same. Both the Ruby service and the Scala service use absolutely the same sources. So after that case study, this is where we're currently at. Here at Whitepages, we have been using Scala for about a year and a half now. We started with one development team, sort of spearheading this effort to pressure test the ideas and the language and the tools and see how the results look like compared to what we had before with Ruby. We were very happy with the outcome, and now we have 4 teams working with Scala with the new tools. We started with one service, and now we have quite a few in the works. Very happy with how that is unfolding. We have also expanded the developers who are working with Scala. We started with a small group, and now an increasing number of developers have moved from Ruby to Scala. And the shift from Ruby to Scala has also helped us fine-tune and maybe modify some of the practices that were not quite in line with the agility goals that we had. So now we have more automation, and John will talk more about that, as well as our processes are more agile and more suitable for the way business is unfolding these days with this type of technologies. So looking forward with Scala and the technologies that we have picked, here's a sample of what we are planning on doing and things that we're working on. We would like to continue the current effort of porting our backend services to Scala, from Ruby to Scala, and we are at the same time we're looking into new technologies to replace maybe older pieces of infrastructure or add new piece of infrastructure into our stack. We're looking at Spark and Mesos. We're looking at Kafka for messaging. And as a side note, let me point out that both Spark and Kafka are built with Scala, so we're not the only ones going in this direction. We're also looking at replacing the current persistent store with the graph-based database. And we're looking at embracing Docker as the deployment technology for the rest of our infrastructure that we're building on. So with that, I'm going to shift gears now and ask John to give us more details into the technology and put some color in the contours that I've painted for you. John?
Yeah, thank you. It's really sort of an interesting greenfield kind of opportunity that we had here. When we started this effort, there really wasn't any Scala in operation here. There was a minimum amount of expertise, so we really started from scratch. And so what that meant on the technology side was we had to figure everything out from scratch. We had to pick what the appropriate software tools were and work our way through what are the new processes and strategies for dealing with this thing. And so this section is going to tell you a little bit about it. The following slide I'm going to let you read through quickly on your own. After a lot of discussion and effort, this is sort of where we have currently ended up in terms of some of the major technology components that we're using. Obviously, Scala and Akka play major roles. Spray is really the heart of our communications infrastructure. We'll have more to say about SBT in a little bit. And on the right column, you see some of the other things that we're using as part of our particularly development, build, and testing and deployment structure. One of the things that we chose to do here which was an interesting decision, is we chose to build our own framework which basically has all of the code that is really common across a wide range of services. We looked at several other frameworks that are out there and decided that we really wanted to build our own, basically because we didn't see anything that quite matched what we wanted, but also it really gave us the ability to custom tailor it to some of our specific needs, and also to have a very agile system in terms of responding to needs that come up as we develop new services. So just a quick rundown. We've got our own configuration system that builds on Typesafe config, but with the ability to do multi-level overrides. We built our own monitoring system. At the core of that is the Codahel metrics system, which lives in a central monitoring actor. Monitoring is handled by sending messages to that central thing, and then the Codahel metrics publish out to visualization and alerting tools. Logging, we started out with Log4j and decided we wanted something that was really more integrated into the Scala world, and we have a new logging system we've developed. It uses a central actor where all the log messages are handled by that actor. And a couple of other interesting additions. Rather than just allowing textual log messages, we allow arbitrary Json content, which allows us to have much richer messages going out. And we've just recently put a new real-time streaming system, so those log messages are actually streamed in real time off of the server boxes to the analytics and alerting boxes. We have a standardized REST administrative API for seeing what's going on inside of these services. And finally, the system is all about the service-oriented architecture. We have servers that listen on either Json or Thrift on HTTP, and we have clients that call out to other of these services written in Scala, but also to a wide range of other things. I mentioned a few things. We have some databases with JDBC, we have Redis, we have Solr as a search engine, we have React, a NoSQL database. And one of the things that we've built on top of Spray is really some more advanced error detection and recovery. I think that was one of the things that got mentioned in the earlier slide. We need really first-rate stuff, and so we have built a common framework that works. And so what happens is when people need to build a new service, all this stuff comes out of the box for free, and then people immediately get into building the business logic rather than worrying about all the infrastructure components. So what's worked and what hasn't worked? I think a lot of things have worked really, really well. I think we've been really pleased. And just quickly here, the fact that Scala's got this concise syntax that's comparable to Ruby, but giving me the strong type checking of, say, a language like Java without the bulky syntax of Java. Everything we do is async. A lot of what we do is really future-based. We've got a lot of independent parallel requests, and we run those through future chains. We make heavy use of immutable collections and functional programming. It's both cleaner code, and also it's the immutable stuff works great in highly concurrent code. Obviously, the addition of strong type checking has been a boost over Ruby code, where you didn't have that strong compile time type checking. Concurrency, we love the Akka and future concurrency model. How many people have built with previous kinds of concurrency systems and race conditions and deadlocks and all kinds of horrible things seem to be the curse of building those systems. We got a whole range of programmers, and we've never, in building any of our services, ever seen a race condition or a deadlock or any of those problems that go along with concurrent systems. They just don't occur, and this is just wonderful when you're building big asynchronous distributed systems. We love Spray. Again, it's the core of what we do. The good performance, the async API is wonderful. We have a love-hate relationship with SBT. We really love SBT as a way of being a Scala environment way of being able to really customize a lot of what we do. On the other hand, it was a painful, steep learning curve to get to the point we're at today. We standardized in IntelliJ. You sort of flip a coin and say Eclipse or IntelliJ. We're on IntelliJ. We like IntelliJ. We're pretty happy with it. All our developers use it. And then finally, I wanted to talk about our friends at Typesafe. We had some sort of slow about setting up a support contract. And we've had one now for a couple of months. And it's been great. They have been an incredible asset. They get us back really incredible answers to very complicated questions, and so we keep asking ourselves, why didn't we get that contract earlier? So those are the successes. Let me nitpick a little bit and go to some of the things that have been aggravations in the technology stack. We got an emerging technology. One of the things that goes along with emerging technology is poor documentation. SBT is our poster child for really poor documentation. It's a complicated, hard to understand system with at least in the past, very poor documentation, and it's been very painful. Even the libraries that go along with Scala and Akka have mixed quality of documentation. We find ourselves not infrequently going and reading the source code of the Scala and Akka libraries to better understand them, and to us this is a failure of the quality of the documentation. The documentation should be good enough. I don't have to do that at least very often. Stable APIs. We've got a system that's been evolving over time. Some of the stuff changes out from under us. This causes a certain amount of pain. Typesafe seems now committed to really stabilizing the APIs, and we love that. But some of the other components in our ecosystem have been troublesome. I'm going to pick on two of them. There's lots of them I could pick on, but these are two that are on my mind today. One was Scala Test put some breaking changes in, and we extensively use Scala Test for our testing, and we had to change literally thousands of tests because of the breaking changes that were in Scala Test. We have some very unhappy developers about those breaking changes. We're currently, we mentioned earlier we're going to use Kafka. The current version of Kafka is still on the 2.10 compiler. We've been trying to get it built with 2.11. It uses the Zinc Scala compiler, which has a backward compatibility bug. We're currently working with Typesafe, and hopefully we're going to get that resolved soon, but that's given us a certain amount of pain. Next, performance analysis. Here's another little sad story. We love the idea of the Typesafe console. We tried it out in various incarnations of it. It sort of kind of worked, but it never really worked, and then finally it was abandoned. We're really disappointed by going down that path, and so now we're left without tools. I understand there's some new stuff out there, but we really haven't had a time to look. I think there may be some great stuff emerging, but you know, again, it would have been nice if we had this kind of stuff earlier, and currently we're flying a little bit blind in terms of performance analysis of what's really going on inside some of the concurrent stuff. Ecosystem. Scala is not nearly as mature as languages like Java and Ruby, and so you know, you're oftentimes missing stuff out there you'd really like. Now, in some cases, you can leverage and just use some of the Java tools that are out there. On the other hand, there's certain things that are Scala specific that have problems. So we're using something called Scala Mock as a mocking library, and we discovered one of the things is we wanted to mock some things that had named parameters, and unfortunately Scala Mock doesn't support named parameters. And so these are, I think, growing pains of the ecosystem at the early stages. Some stuff wasn't there at all. Until fairly recently, there wasn't really a good code coverage tool available. There's now one that we're using called S-Coverage. In some cases, there are too many options. We know of at least 10 JSON libraries, and we suspect there's others out there. Which one do you pick? And if you've got one component that uses one and another that uses a different one, it's really hard to do the integration. There's a ton of Scala GitHub projects out there. We've been a little bit gun-shy to do them. The quality is variable. We've seen a number of them abandoned. There's nothing worse than picking something as a key component of your life and as a component, and then find the developer support, the people supporting it just disappear and go on to some other shiny object, and that's been painful. Debugging. Scala compiles down to, in a lot of cases, it sort of compiles to sort of obvious Java bytecode, but some of the more advanced Scala constructs get compiled into really weird bytecode, and given the fact that debuggers tend to work on the bytecode, debugging can be difficult. Also, the concurrent constructs, futures and actors, really introduce significant challenges in terms of how to do debugging. Language issues. We can pick on Scala. I love Scala as a language, but it's got some flaws. The top of my list is type erasure. it really is a horrible thing. It causes a lot of developer confusion and errors. Yes, there are some workarounds, but calling them awkward is maybe is almost too kind. And I'll just pick on a couple of other minor things. There's in Akaland, they fixed it so that the props thing for actor constructors are not type checked at compile time, and it's a runtime check. This is we've had things break on that on a number of occasions. It's annoying. Also, some of the more advanced stuff in Scala, some of the really clever DSL type things in Scala let you write things that look simple, but oftentimes you really need to understand what's going on, and boy does it get confusing trying to understand what's going on underneath it. I mentioned implicits here as one of the things that can make code really, really difficult to understand what's going on. Finally, just as an overview of technology, I've talked a lot about some of the issues and problems we've had. We're really pleased that with Typesafe on board, there's been some incremental improvement in a lot of these things, and we expect to see more. You know, I think overall, despite the fact I sort of talked about some problem issues here, we really love the technology. We've had really great success, and we believe the benefits by far outweigh the problems. So that's sort of the end of the technology section, and I'm going to turn it back over to Dragos to talk a little bit about our experience in people and moving them from Ruby over to Scala.
All right. Thank you, John. People. Scala is a language, and the whole stack that we have been adopting here at Whitepages requires practice, requires people using the tools, using the language, and building expertise incrementally. And naturally, as with everything else that requires practice, the developers span the gamut here. So we have folks who have just started using Scala, and we have at the other end of the spectrum, we have folks who are Scala experts, having been using it for a number of years, and all sorts of intermediate stages in between. Just to pick two of the points here that I have on the slide, the beginners tend to be folks who have a good comfort level with object orientation. They understand the abstraction, they understand polymorphism, they understand how to abstract their domain into classes and represent it like that. At the other end of the spectrum, we have folks who have been building Scala software for a while, and they are experienced, they are seasoned. Now they can define and craft APIs that are going to pass the test of time and be reused from very different services under very different circumstances. And all sorts of other intermediate stages in between. Now, functional is one of the things that comes to mind that's different and is becoming increasingly important. The variance with respect to the developer know-how here in Scala is compounded by the fact that Scala is quite different than Ruby and other languages because of the heavy functional slant. And I should just single out Ruby here. It goes with other languages that tend to shy away from the functional features. But in this case, you know, being different is one of those circumstances that makes you smart. And I want to remind you, if you remember Paul Graham's article from about 11 years ago, Beating the Averages, where he was describing how they built the Yahoo stores using Lisp, which in Eric Raymond's words was the secret weapon that they had against people who at the time were building websites in Perl and C++. So the functional paradigm and the power that gives us is something that makes Scala a very interesting language to build these types of applications in. So typically, to leave you with a thought here, don't strive to pick developers that fit, let's say, the high end of the scale. Our teams, we have the developers that cover pretty much the entire spectrum. So we have a mix of experienced and beginners, and they all work together, and they pull the project forward, and they learn it, they get better. Now, having covered that, how do you put together a team of Scala developers? And there there are interesting times now in the Scala community. Scala is definitely on the rise if you look at what has happened over the last few years and the number of attendees and conferences and open source projects. However, it is still eclipsed by the number of developers who are fluent with Java and Ruby because those languages are much, much older than Scala. And many shops are still stuck in the past, or they're conservative. They prefer Python over something new like Scala because maybe Scala is too risky, or they prefer Java and C++ and Ruby because they have a great pool of developers to pick from. And at the end of the day, you can think of it as a chicken and an egg problem. We have found that mixing a number of experienced developers with beginners is a great strategy for having the beginners get up to speed really quick and become productive. And last but not least, from our vantage point, it looks like choosing Scala and the related technologies is a self-selection strategy. We attract people who are motivated to learn new things, who are motivated to push the envelope and grow professionally, and we like to work with those kind of people. All right, so speaking of people, where do we find these guys? So far for the Scala world, our best successes have been personal networks. So just to share from my perspective, I got involved with Scala through personal contacts about 3 years ago. I was doing some freelance work with a Bay Area startup, and they said, hey, we'd like to do Scala, and I never programmed a line of Scala in my life before. And I said, sure, I'm happy to learn Scala alongside with you guys. And I believe now a few of those folks are on the ACA team. So I think, and that's a great story about how you should not be scared. You should grab the bull by the horns and move forward. Currently, Scala has traction, and there are lots of meetups. We have one right here in Seattle that we're hosting at the Whitepages offices, and John is the organizer. And I believe recently, John, we have passed the 500-member mark for our meetups. So great success, great story, great traction. Lots of folks interested in meetups. These days, now that Scala is no longer something that happens only in academia. We have lots of conferences that cover Scala. There's Scala Days. I talked about it a little bit. About a month ago, I was at OSCON. There were lots of Scala sessions there and conversations about Scala. So great time to get into the technology. Great traction. Fantastic place to recruit people and great venues to find like-minded folks. However, you should not look and talk only to folks who are fluent with Scala. We have observed that there are traits that some developers share that would make them really easy to get into Scala and become proficient. So we're looking at not necessarily folks who have Scala on their credentials, but folks who have done work in functional languages tend to fare pretty well. Seasoned Java developers who are sick and tired of the syntax, they want to maybe push the envelopes, are pretty interesting too. As well as folks who have done work with active frameworks, Erlang, OTP. These are all traits that you should look for, and anybody who's done work with any of these technologies or a combination thereof would make a good Scala developer. All right, so now that you found them, how do you attract them? And this is an area that both John and I have experience with. We have tried really hard in the past to pitch Scala to various employers with maybe questionable success. One interesting and good thing about Whitepages is that here the support comes all the way from the CTO and CEO. They're both very supportive of advanced technologies. And that's a question that you need to ask, if you're on this side of the fence looking at maybe finding an employer, you want to see whether they are progressive or maybe they're stuck in the mid-90s. So we already mentioned to you a few technologies in addition to Scala, Kafka and Spark. These are all on the bleeding edge. People who are using these technologies are not afraid of moving there, and they're gonna charge forward really fast. Other things that we do, we have a fantastic office here in Seattle. Anytime you're in the area, drop by and say hi. And Scala specific, I thought I would throw this in. All our developers have state-of-the-art Mac machines, developer machines. We all use solid-state disks, which makes Scala development and compilation a breeze. So every now and then I end up building some code on my home machine which doesn't have a solid-state drive. It's a pain. Having state-of-the-art machines is very, very nice. It's a selling factor for us when we talk to potential recruits. So besides recruiting people who are fluent with Scala, another way to get them there is to actually find folks within the company who are interested in growing professionally and interested on hopping on the Scala train and getting up to speed quickly. Luckily, these days there's a wealth of material available out there. I'm not going to read this slide for you. You can have a quick look here. There are books, courses on Coursera. There are free, all sorts of trainings. And just as an example to give some color to this slide, at OSCON I had Shadaj Ludad, who's a 14-year-old, give a keynote. And he was very adamant about it. He talked about his story about learning Scala, and if a 14-year-old can learn Scala and give a keynote at OSCON, I think smart developers can too. Besides the external resources at Whitepages, we have put quite a bit of thought into internal training. So our developers are all co-located. We all work together. We have desks next to each other. Our office layout, as a matter of fact, is configurable, so we could roll our desks to make sure that we apply the reverse Conway's law, so we want to be next to the folks with whom we talk to the most. We tend to favor personal interactions here, so it's much more efficient to sit next to someone, maybe an expert, to ask questions to understand how to do various things, how to write some Scala code, how to debug some Aga code, versus one of these other mechanisms that people have at their disposal that have been successful for distributed teams, but they are not as effective when the teams are co-located. And we also have periodic engineering talks that we record, and folks who want to get up to speed quickly, let's say for onboarding, they could view these recordings and understand about our frameworks, about our systems, about some of the training that we've done here, and benefit from everything that has happened before they join Whitepages. And I already mentioned that. I'm going to throw it again here because our meetups that we run locally transcend Scala. We host other meetups on scalability and ops, and we had a couple of Spark meetups here. So there's lots of meetups that we host on site. This makes it really easy for developers to just slip from their work schedule into a meetup. You don't have to actually go anywhere, commute, take a bus, take a train, whatnot. It's all happening here on site. All right, things that have worked for us as far as internal training is concerned. We have encouraged folks to, particularly people starting with the new technology, starting with Scala, starting with Reactive, to find a mentor and meet with them periodically, maybe pair program, maybe pair design, do personal code reviews, all these techniques that emphasize personal interaction. There's been a great success story for us. We tend to favor personal interaction over pull requests because the locus to explain and explore design choices is here rather than getting lost in the ether. Having said that, not everybody, not all of our developers have been super happy at the end of this immersion into Scala, and some of them got through it. They wrote some Scala code, and they decided that no thanks, we want to go back to Ruby and the old ways and do things the way we did them before. That's fine. This is a personal choice. The great majority, though, are very happy Scala programmers. They have been now building several services that they have under the belt. the level of Scala code is getting increasingly sophisticated, and as John has mentioned, we're looking at several other technologies built on Scala. We're struggling to build Kafka right now, and messaging and graph databases, and all these other interesting technologies that we want to put in. So here are some common traits that we identified when looking at developers who have gone through this Scala immersion, and they came out of it enthusiastic and heavy programmers and effective in doing their work. They are typically folks who are interested in new technologies. These are the guys who go and scavenge Coursera for classes about new languages, new techniques. People who instead of checking Facebook on the bus, they pick a new language to learn, and they make that their personal goal. Also, people who want to learn about different ways to think about problems. An example here comes the shift that has happened from maybe Hadoop to Spark. That's a different way of thinking, and people tend to push the envelope and be inquisitive and try to solve old problems in different novel ways. We also noticed that the folks who have had exposure to functional languages tend to fare better. A fair amount of college courses on programming languages have used a Lisp scheme or combination to teach people how to write programs, and folks who have had previous exposure to functional concepts tend to hop into Scala and leverage it faster than folks who haven't seen functional languages before. And also because of the way we have been doing our mentoring, our training, we noticed that folks who like to work with others, who don't mind sitting down and pair programming, peer reviewing, designing with someone, testing, debugging together, they tend to be more successful because, again, of the emphasis on personal communications. So having said that, I want to share with you a few of our thoughts, a few of our findings regarding things that we would like developers to maybe approach with caution, particularly when they're new at Scala, because we don't want them to abuse the language and get burned. Before I start this, let me remind you that Scala has celebrated its 10th birthday earlier this year. And the evolution has been quite fast. Looking at my own experience, when I started with Scala, the try monad did not exist. The string interpolators did not exist. So lots of the first order derivative is positive and quite large. And there are some Scala features here that tend to give new developers headaches, and we try to tease them out and maybe use them as trigger points for discussion of design trade-offs, alternative ways of doing things, and conversation points. Things that if we see in a code review, we're going to bring up and say, hey, let's talk about different ways of doing this. Are there different ways, better ways, easier ways to do this? How would you accomplish that? So with that, here's my cheat sheet that we put together. I'm not gonna read it all. I know whether John, do you want to pick one or two to maybe add additional color to what I've said so far?
No, other than to comment, in the case of a number of these, it's an ever-growing list, and we find as we go forward that we get bugs in code or awkward experiences, and oftentimes it tracks back to particular things. One example is lazy vowels. I always thought lazy vowels was a really cool feature, and it is. On the other hand, I know of at least 3 cases where people have gotten badly burned as a result of lazy vowels doing something weird. And so it's not that lazy vowels are a bad feature, but it's a little bit different than people are used to, and there are ways of getting burned. And I think because comparable comments can really be applied to pretty much most everything on the list as well.
Now let me throw another one here that I happen to have dealt with in the past. That is the Scala enumerations. Anybody who is interested in implementing enumeration in Scala has several choices. One of them is to use the enumeration class. The other one is to use case objects. If you go to Stack Overflow, there are pros and cons to both approaches. none of which is perfect. No, each has its own pluses and minuses depending on whether you want to enumerate all these values that you have in enumeration, or whether you're interested in serializing them or not. Again, this is one of those indicators that, hey, there are multiple options of tackling this. What is it that you want to do? What are the constraints? Which is the best way to go? Lots of resources out there for us as a trigger for conversation during a code review. All right, so with that, I think I pretty much have covered everything that I wanted to share with you all regarding the people component of our shift from Ruby to reactive using Scala, Akka, and related technologies. I try to add color to walk you through what does it take to grow people in-house as well as find people on the outside and bring them in. And on that note, I cannot move forward without telling you that we are hiring. So if you resonated with any of the things that I've mentioned to you or John has covered, feel free to reach out to us. And this marks the end of our talk. So we'd like to thank you all for your time. We appreciated the opportunity to share our experience with you. And if there are questions, maybe we could try to answer them now.
Yeah, thank you so much, John and Dragos. That was fantastic. Really enjoyed it. Before we go into the Q&A session, I just wanted to touch upon the developer subscription that John brought up a little bit earlier before we dive into the Q&A. So Typesafe, we do offer annual developer and production subscriptions. They complement our platform. And these subscriptions include certified build, professional maintenance, and support, and operational tools. And then we also do things like production readiness reviews, which we walk you through a series of checklists to ensure that any potential blockers to having a successful deployment of your application are just on your radar ahead of any upcoming production launch. And our goal here with these programs, and really all of our programs at Typesafe, is just to mitigate your risk and ensure that you're successful. So with that plug out of the way, let's dive into some questions. So, guys, what was the Ruby team's experience with statically typed languages before the transition to Scala? Have you noticed any particular favorite aspects of the type system on your team?
I think it varies a lot with the individual developer. Some had no experience; others had worked with other statically typed languages. One of the things I noticed was there was this sort of like switch that got thrown. Everybody was living in this sort of untyped world and being perfectly comfortable, and then suddenly we moved into a strongly typed world, and suddenly everybody said everything has to be strongly typed everywhere for all purposes. Obviously there's some, you can use weaker typing constructs in a number of ways in Scala. We've almost got people that have become strong typing bigots who've made the move. They've suddenly not only embraced it, it's the end-all answer to the world. And I personally feel more comfortable understanding the trade-offs between statically typed and dynamically typed languages. I think each has some benefits. And one of the things we mentioned earlier in passing was doing metaprogramming has turned out to be a really bear of a problem in statically typed languages. It was a real easy thing to do in Ruby. And so that's one example of maybe some of the pain that we've had.
Okay, great. So you mentioned before that you built a custom logging system. Were there any off-the-shelf monitoring packages that you looked at before, or any advice you have for larger organizations that need to build a robust monitoring and logging system?
Sure. I think you've got two different things here. There's the monitoring and logging. Let me take monitoring first. We love Code to Hail metrics. I think lots of people love Code to Hail metrics. If you haven't seen Code to Hail metrics, go check out Code to Hail metrics. It takes care of a lot of the aggregation functions. It also takes care of, it's got a large number of ways of publishing to external things. All we did was wrap it with an actor. So the amount of work in setting that up was fairly modest, and it shouldn't be too hard. Logging, things like Log4j and Logback and those kind of things have been sort of standards in the Java world, and a lot of people in Scala use that. In Akka uses a strategy similar to what we have. Akka actually has a logging actor that runs off the event bus for Akka. So we had a mixture. We had Java things with Log4j. We had Akka stuff. But we wanted to do something that was a little bit more state-of-the-art, so we switched from Log4j just recently over to our own custom system. One thing we didn't mention, which we're hopefully is going to be in our future, is the framework we talked about that includes both the monitoring and the logging stuff. We are actively working on the process of trying to move that out to open source, so we're hoping to have that sometime later this year out to open source, and so you might take a look at that when we release it.
And let me add one more thing here regarding off-the-shelf monitoring packages. We have looked at several off-the-shelf monitoring packages, and they tend to fall into one of the two categories. So there's a family of monitoring tools that have started as monitoring, front-end things that you put on your web page, and you see how many impressions you've gotten, that sort of thing. They started with front-end languages, and they sort of expanded now to cover some of the more traditional back-end languages. And there's the second family of monitoring products that started in the back end, and now they're bubbling slowly towards the front end. The problems that we noticed with most of these packages is that they worked well for languages like Ruby, where you have a clear flow of control. By the time you throw in actors, futures, or combination of both, they tend to fall apart. So it is really, really hard to time the execution of something that's going to end up being a message to several actors, that each of which contributes to the processing that you're doing. Same thing with futures. So that's one of the drawbacks of these off-the-shelf. They all have pretty GUIs. They save you a lot of work. However, when you want to push the envelope and take them to uncharted territory for mainstream languages, like I mentioned earlier, Ruby, JavaScript, Python, all these, they sort of fall into concepts like futures and actors. Then these frameworks no longer work well. And to be fair here, not even Coda Hail metrics works very well with actors. There's a timer facility there that assumes that you have access to a context for timing. At that context, you need to pass it between actors and serialize it if you need to leverage that part of functionality in an actor context.
Okay, that's helpful. Thank you. And one of the attendees kind of requested that maybe they can see some code samples to better understand your perspective on some of the slides that you presented. So maybe we can put you in touch with them, and you can share some relevant information if it makes sense.
Sure. Also, I mean, I would have loved to have included more code samples. We went for at this talk more about breadth rather than depth, and hopefully we're going to be doing some future talks on that front, and potentially making those available online as well. I'd love to do it, but yeah, please get in touch with us, and we're happy to chat offline with you and see what we can help you out with.
Great, thanks, John. So switching gears, so you mentioned in your presentation to avoid actors, and this person asks, how can you be reactive if you're avoiding actors?
Boy, that's a great question. I wish I had another half hour to talk about that. It's a really interesting topic. Let me just touch on it a little bit. We don't avoid actors. I just mentioned in logging and monitoring we use actors, and we use actors in a number of ways. So we're not avoiding actors. On the other hand, a lot of what we do, our typical use case on these back-end services is we get a large number of requests in. The simple request is, here's a phone number. Who's that phone number associated with? And I get several thousand of those in a minute coming into a server box. And by and large, those are independent of each other. And we found that dealing with the basic request flow logic, we don't really need an actor where those things come together. We handle them largely with future chains. And futures have some advantages over actors. They're more composable. Actors don't compose terribly well. There's no bottleneck. If you feed things through actors, you get bottlenecks because only one person can be in the actor at a time. On the other hand, there are places where we do use actors. So again, topic for probably a whole talk in itself at some future point.
And let me add one more thing to that. There's nothing about being reactive that requires you to use actors. Actors is one of the many potential technologies for implementing a reactive system. If you look at the reactive manifesto, you see there are things like responsive, scalable, event-driven, resilient. None of those things require actors. If you look at how others have implemented reactive systems on other platforms, for example, Java doesn't really have actors. They have a reactive Java. On the .NET platform, you have iObservables. There are no actors there. You can build successfully. And at the time, I built reactive systems on .NET. So it is an implementation choice. You can use many other mechanisms to build scalable, event-driven systems. So the fact that we're not littering our code with actors does not mean that that precludes us from building a reactive system.
Cool. That's helped. Thanks for going into that, guys. And I think we can also maybe have a follow-up blog post if you wanted to elaborate in more detail. Could be kind of an interesting topic to explore more. So I thought we'd wrap up with a question that was just submitted that I thought was kind of a nice one. Was there any one aspect of your original production deployment or infrastructure that you wish you had prepared for a bit earlier in the development cycle?
Well, one of the things that happens when you're launching a new technology is you got a million balls in the air simultaneously, and the problem is not one ball; it's keeping them all flying at the same time. We sort of pick things off in priority order. We pick the ones that were most dire initially. One of the ones that pains me the most that I haven't talked about here, although we talked about it in passing, is we're currently using Chef as our basic deployment mechanism. And if we had another hour, we could have a discussion about why I think Chef is the wrong technology. Anyway, we're in the middle of transitioning to a system that integrates some Scala reactive stuff with Docker, and we're really excited about that. And deployment is a key is one of the key things you need for agility. If you're going to have a really agile environment, you need really easy to use deployment tools that react very, very quickly. And so that's one of the things at the top of our mind right now, and I'd wished we'd been able to tackle it earlier, but again, the plate has been pretty full, and it's just now rolling around to the point where we actually have a few cycles to go after it.
Okay. Dragos and John, is there anything you wanted to end with? Any last comments on the Q&A session before we wrap up?
No, again, we want to thank everyone for attending, and hopefully everybody got some interesting stuff out of it. Please feel free to contact us if you have questions. We're pretty open. And if you're in Seattle, stop by either at Whitepages and/or we have a Scala meetup here where we have some pretty neat talks, and we oftentimes go into a number of the topics we've touched on the edge here in more depth in those meetups.
Absolutely. All right, guys. Well, thanks so much. This was great, and everyone, thanks for joining us today. Hope to see you on future webinars, and look for the recording within a day or so. We'll be posting it on our YouTube channel as well as the website. Thank you.
Fantastic. Thank you all.